So I'm going to be talking today about silica dust, particularly the type of dust you see around work sites that one breathes in. Typically, the experience of breathing in dust is that you'll get a gritty taste in your mouth, in your nose, that kind of thing. That is really not the dust that we are particularly concerned about, because the body has quite good defenses against the dust you can see and feel. So the stuff that we are concerned about is the stuff that can be breathed into your deep lung. And it's usually just nuisance dust, and we experience it in everyday life. The body is quite well adapted to dealing with it. People live in deserts and the wind blows. However, silica has been discovered to be somewhat hazardous. I say somewhat hazardous, even in low concentrations, but particularly over long periods at high concentrations. So this isn't really from medical studies per se. It wasn't an Aaron Brockovich story. It was rather a statistical story, very much like dust that you find in woodworking factories, where they just took a sample of people who never worked in a woodworking factory, compared their health over a period of time to people who worked at IKEA factories or something like that. And they found that as people aged, the quality of their life decreased due to lung complications. So the story of silica is one of old age and the unpleasant nature of losing your capacity to breathe as you get older. And so OSHA stepped in, and these laws were proposed. They are now official, and in 2021 they applied to fracking. OSHA has not really implemented to the maximum extent that, say, asbestos has, but it is a real concern for industry and, of course, for people to be aware of it and to know that it does affect, ultimately, our health as we grow older. And you can see at the bottom, it's been linked dramatically to lung cancer, to silicosis. I say dramatically because sometimes when we state you can get lung cancer from it, then there are resistance in there to say, well, I know many people who never got lung cancer. So it's not really that we need to go to the most dramatic outcome. It's that intermediate one, again, which robs quality of life as you grow older. And in our modern life, when we grow older, that's a good time in our lives. That's when we should care about people who work with us, for us, and ourselves. Oops. So the aspect that the technology that I'm going to be discussing, which is dust collection, applies to is engineering controls. First line of defense against dust is obviously respirators, some kind of breathing protection. This used to be the leading point of safety. Fit tests, the quality of the filter, blah, blah, blah. Well, it's determined that in the real world, when people have beards, or they're hot, Texas, they're sweating, they're moving their masks, PPE, although extremely effective, is not reliably used by the people who should be using it. Just practically. So there's huge enforcement, huge training, huge follow-up that is involved with PPE. So OSHA, everybody's pushing towards environmental control. Environmental control is what is the air like in the general space we are working. If everybody was smoking in this room, the environment in this room would be bad and we would be breathing in secondhand smoke. So we could all put on masks, or we could say, suck the smoke out, put in fresh air. So with dust collection, dust collectors, the machines, we are really looking at changing the environment where people are working trying to capture the dust at source, if there's a loading operation, a conveyor transfer station, something like that, or just a containment, a big tent, something like that. In all of those applications, a space that is enclosed or where it can be captured easily, that's where you could then suck that dust out of that environment, filter it, and remove it, so nobody can breathe it in. So in a nutshell, OSHA is trying to limit, not eliminate, limit the exposure of people to the dust that they will breathe in. So this is where dust collectors come into play. You see them on every frac site where dust is handled. These machines work. They have filters in them that are regulated, their efficiency is high enough that they comply with legal requirements, and they can be deployed. But I'm a mechanical engineer. I've spent my life working out at remote job sites, out in Kazakhstan, Saudi Arabia. Those were India, terrible job sites. The problem with all equipment is not how it operates and what it's specified to do, it's this condition. It's where the job site is inconvenient. It's just darn difficult to work there. So, imagine you have to do a filter change in this environment. How do you do it in this machine? You have to open those doors. You have to pull 50-pound filters out, covered in concentrated, airborne, dust size fraction dust. That is a miserable task to do. So now we have the stuff that was floating in the air as concentrated cake on those filters. That somehow does not seem like the smartest thing that we can do. Or let's assume the auger, for some other reason, got jammed. Bearing failure, something got into the supply, and the auger is jammed. Now you've got a man having to climb in through one of the ports with a dust collector belly full of this fine dust, and he's got to dig out the auger. Not a great day either. You need the machine running, so that auger needs to be clean. Or the tires are flat. I'm sure you've all experienced that too. Now you've got to move the dust collector, relocate it, and one of the tires is flat. Well, you've got to change that tire. Or the engine's having trouble. These machines have pulsing systems. Often, when the dust collector goes offline, the battery is left connected, like leaving the lights on in your car. Now the battery's flat. The dust collector won't start. Or the engine has a problem. There's a bad diesel injector. So there are all sorts of real-world problems associated with operating a piece of equipment that is there for safety. So the equipment itself becomes the problem. Filter changes. You say, okay, well, we don't ever see unscheduled filter changes. Most of the machines that go out onto site, their filters are removed from the top. You pull the filter, 50-pound filter, out through the top of the dust collector, through the clean air plenum. So think about that. You've got a loaded, spent filter, covered in dust. You are pulling it out through the clean air plenum. All the dust falls off that filter as you're pulling it out. So there's a man up there, it should be tied off. And the dust is falling off into the clean air plenum. How are you going to clean the clean air plenum? 99% of the time with a compressed air hose. Illegal. So now we've put a piece of equipment onto a job site asked a man to change the filters because it's clogged, it's time. He has to open a set of doors 13 feet up, pull a dirty filter through the clean air plenum, and then clean up after himself. That is not good engineering. And it's actually surprising to me that we regulate the air that we breathe, but when it comes to maintaining that piece of equipment, nobody's thought about it. So in the ideal world, you don't want to handle contaminated filters, and you want to change filters quickly. Get them changed, get the equipment back online. So this is where the smart box, it's such a simple concept, comes into play. It is simply where you take all those filters, you encapsulate them in a box, and you integrate around that box an air distribution plenum. A way to spread, so the air comes in from one side, goes around the outside like a big halo, and is distributed in between the filters. So the air comes in here, around the sides, you see there's little slots, and it distributes all the dirty air across those filters, and the clean air comes out of the top of those filters. So this is the clean air side, this is the dirty side. Air comes in, filtered, and that whole box, standing over here, you can see the relative size, is then exchanged, like an inkjet cartridge. So now, you can change all those filters by simply lifting the box out and putting a new one in. Now you take that box away and you deal with it in a nice, easy place, either a recycling center or something. Now you can deal with it in the shade, off the job site. Or in the case of some of our jobs where there'd be things like asbestos or radiator dust, it simply gets discarded completely. Now because we've got a smart box, there's various options of what you can do with the dust. You can either capture it in drums, super sacks. You can transfer it with an eductor, something like that, to a storage silo. If you're putting it onto a transfer station on the conveyor, you can leave it open. So you capture the dust from the conveyor, you pulse the dust straight back onto the conveyor. We've all seen these huge transfer stations and the belts with a Donaldson or something mounted on top. Again, a nightmare to service. With this concept, you'd simply crane up a smart box. It's time to change it, you take it down and put a new one up. No more servicing the filters, nobody touches it. As I said, there are various configurations that you can use, plus more that we can embed to deal with that dust. One of our standard applications for sites that have, say, bad ground is that we mount the whole system on a roll-off container. The dust can go straight into the belly of the roll-off. You've got the dumping facility to recycle that. So this is one application where you can put about 10 yards of dust straight into a roll-off. When it's full, take 10 yards, dispose of it. Or just bring in a replacement unit and drive that off to somewhere convenient to handle. Maybe put that chemical, there we go. It's good dust. So the beauty with a roll-off container, no flat tires. You can place that thing anywhere, in a mud patch, whatever. It's robust. It can be moved, it can be dragged. It's weather resistant, forklift resistant, and there's a lot of trucks that can move it around, remove it or bring it. So it's easy to relocate, easy to run. Another thing with with the modularization with these smart boxes is now you can create machines of different sizes. For instance, it can be several units tied together. They're all parallel processes. So you can have a very large unit, you can have a smaller unit, put it on a flatbed truck rather than a roller container, whatever. You can see, you can have all these different units, and depending on the application you need, you just tie units together. Like the memory in your PC. You can just add banks of memory. So the size of the dust collector you need is now just a question of how many modules do you tie together. So by turning it into individual smart boxes with their pulsing systems to clean the filters and their catchment, you can grow it indefinitely or have it really, really small. It can be a standing unit if you have other dust collectors working and you just need to bring it in during a maintenance outage. You can just bring in one of these units as a standard. It can go into just a box truck, anything like that. So deployment, modularity are key to the operability of a useful dust collector. And I want to end the talk going back to where we started, which is the mandate by OSHA for health. I was involved in some of the studies that they did where they looked at lung damage caused by silica. And we're talking about extremely, extremely fine particulate, sub-micron down to the 0.1 micron. So it's a very small fraction of the dust that's produced. And how that gets into the deep lung, right down into the bottom, where it does small damage. It's really small damage, little cuts, little scratches, little irritation. And so what happens to the lung is because of the presence of those very, very, very small silica slivers, you get scar tissue forming in your lungs. If you go to a respirator, scar tissue forms. It's also a bad thing. So imagine breathing in silica over years and years, and systematically your lungs are developing scar tissue. Scar tissue makes your lungs stiff and changes the capacity of them to operate and to take oxygen out and to breathe out. So this is what happens as we age, this accumulation of scarring. Just like you will not get skin cancer from one sunburn, but if you're continuously getting sunburned, after some time your skin changes. It does not mean you will get cancer. In the case of lungs, it does not mean you will get lung cancer. It's a possibility. But certainly there will be a systematic development of scar tissue. So even though the rules of OSHA feel like a burden to productivity, to costs, I think if we think of ourselves and the people we work with, it has merit.
You probably hit the button at the bottom.
There we go. Questions?
All right. Thank you very much. Any questions from the audience? Oh, we have one there from Jason.
So I wanted to ask, how long will one of the smart box modules last compared to the more traditional, big bulky equipment? Just curious about savings versus cost.
So we've had smart boxes running for 3 years without needing any attention. The issue is really when some unknown contaminant gets into the unit. It is true with all filters this way. So we have a pulsing system. We actually have a system where we pulse and shake. So we're rattling it off and we're reverse, getting reverse flow. So if the dust quality is good, they essentially haven't basically an infinite life. And let me just qualify why that is true. You start off with your filter fabric. The filter fabric, when it's new, gets loaded with a layer. The filter is never clean again. So there's a layer on it. You want to make sure that that layer on the surface of the filter is not compacted. If it becomes compacted, the filter gets blocked, and then it's time to replace the filters. So if you can keep that layer that touches the thing open and fluffy, as it were, through the pulsing, all the wear and tear on the filter is actually done to the dust on the filter. So there is nothing impacting. Over time, small particles will start working their way into the fabric and block the fabric itself. In our particular filters, we use a Teflon laminate to really work against the impregnation of that fabric over time and systematically blocking them. So they don't wear out, and because of this Teflon laminate, it's a real little film we put on there. It's not a spray-on, it's an actual multi-layered system. We're working against the filters plugging up as the months go on. I don't know if that answers your question. It should be counted in years.
That does. One more question. Is there a limit to how many of those boxes can be put together?
Well, there's just a practical size limit of handling. So we would say, we don't like to go more than 6, and then you just go to a second unit. And a third. So then you can stack them side by side. We've got one application that we're working on with Tinker Air Force Space, where we're actually stacking them vertically, because they need 26. So they can go vertical or sideways. But there's nothing stopping them being used as a bank of lots of individuals, 6 tied together. It's purely a practical question of transportation, handling on site, what lifting equipment you've got, going offshore, whatever the limitations are, you can just bolt them together as you need.
Got it. Thank you.
Okay. Another question from the audience? Okay, I just have one, almost on the economic side. Is this the same cost as the traditional systems? Like we get the safety and the advantages. What about on the cost side? Is this also saving money, or is it costing a little bit more? How have you figured out those cases?
Right. So the total cost is the same. Filters are the same. The steel is the same. The smart box in itself is slightly more expensive because we've added the box.
Yeah.
However, that is immediately recovered on your first filter change, because at that point, you're able to obviously reuse this filter, but you're saving all the downtime, the labor and everything. So you buy 2 smart boxes, one goes in, the other one comes out. So you have to double up on that. So the initial cost is an extra smart box, which you get at the point of servicing. So you own 2 instead of 1. Propane tank. You own 2 propane tanks with your grill.
Okay.
But otherwise, the cost is the same.
So after a year or 2, it's a net savings.
Correct.
Okay.
Exactly.
Perfect. Last chance for a question. Everybody's thirsty. I got it. Okay. Well, thank you very much.